Assalamu alaikum guys, welcome back. This is Shafat Khan on your screen again, and we are back with the chemistry crash course of AS Chemistry. Right guys, so we are on lecture 7 now. We've made 6 videos so far, and now let's get started. Alright, so now that we've moved on to a new chapter, that is the atomic structure and moles and stoichiometry. Of course, that's a separate chapter and this is a separate chapter, but of course the major points have to be discussed over here. So most of it is going to be the revision, because I'm assuming that since this is a very basic chapter, still many students find it challenging. I don't know why, but if this chapter is weak, then of course you will find the rest of the chemistry challenging. So it's very important for you guys to concentrate here. Let's begin. Alright, so what is an atom? The very first definition of an atom. Atom is, by definition, it is the smallest particle of an element. It is the fundamental particle of an element. You guys know what an element is, right? Element is a very pure substance that is made up of only single type of an atom. Okay, a very pure substance that cannot be further purified is an element, and that particular element is made up of a single type of an element. For example, bromine. Bromine is made up of only bromine atoms. For example, chlorine. Chlorine is made up of only single chlorine atoms. For example, oxygen. Oxygen is also made up of oxygen atoms, and so on. Now guys, atom is the smallest particle of an element that takes part in a chemical reaction. Okay, this is the complete definition of what an atom actually means. And it has the same chemical properties as the element itself. Okay, chemical properties of the element and chemical properties of the atoms are not going to be different. Okay, for example, hydrogen gas has the same chemical properties as the hydrogen atom. Okay, hydrogen atom and hydrogen gas, both of them have the same chemical properties, although the only difference is that the hydrogen atom is going to be more reactive than the hydrogen molecule, but still they have the similar chemical properties. Okay, if you burn them, both of them will give you water. If you react them with oxygen, both of them will give you water. That's one chemical properties. Chemical properties mean the properties that they exhibit during a chemical reaction is a chemical property. Simple and easy definition to learn. Okay, then they cannot be further broken down into simpler substances by chemical means or by physical means. Although we do know now that yes, atoms do have subatomic particles as well, but you cannot split an atom into their subatomic particles very easily. You have to go on into very extreme conditions. Okay, for example, the accelerators that we use in physics, like very advanced physics, the high velocity accelerators, and then they collide the atoms at very high velocities, and then you get the atoms being splitting out into their subatomic particles. But again, that's not possible in a school lab or a school laboratory or under lab conditions, right? So they cannot be further. So in our syllabus, we are going to assume that they cannot be further broken down by simple chemical or physical reaction or chemical and physical processes. Okay, then the subatomic particles. Subatomic, what does subatomic word means? Subatomic means the atoms which are present inside the substances or the species found inside the atom. Subatomic, inside the atom. Subatomic particles found inside the atoms include, there are 3 types: protons, neutrons and electrons. Out of these, the protons and the electrons, they are charged species. Okay, meaning they have charges. Protons are positively charged, P for proton and P for positive, so they are positively charged, and electrons on the other hand are negatively charged. Okay, neutrons are not charged at all, they are neutral. Neutron and neutral mean go hand in hand, right? So from neutral, remember, they are neutral, therefore they are neutral, therefore they are called neutrons. They are neutral. So neutrons are neutral, therefore they are called neutrons. Electrons have negative charges and protons have positive charges. Okay, so these are the relative charges that I've written over here: +1, 0 and -1. Actually guys, these are not the actual charges of these species. Okay, as you know from your physics and from your previous O-level physics, that charge of a proton is not +1, it's something different from +1, right? Charge of an electron is not -1, it's different from -1. Remember the charge of an electron? Well, it's 1.6 raised to the power of -19 coulomb. This is the charge of a proton as well as the charge of an electron. Okay, for an electron it's negative 1.6 raised to the power of -19 coulomb, and for a proton it's positive 1.6 raised to the power of -19 coulomb. This is what you know from your O-level physics, right? or your previous chemistry or your A-level chemistry. These are the actual values of charges, but the charges that are given in these tables over here, in this table that you might have seen frequently in your O-level textbooks or in your A-level textbook, this table actually gives us the relative measure, meaning it's a ratio, it's a comparison between the proton and the electron. Okay, proton and electrons have equal charges, but they are opposite in nature, so therefore it's +1 and -1. Okay, and then neutrons have no charge, so they have a 0 charge. Then after this comes the relative masses. Protons and neutrons have equal masses, so the relative masses are gonna be equal, 1 and 1. But electrons are way lighter than the protons and they are way lighter than the neutrons, so therefore their charge is 1/1840, or some textbook quote this as 1/1836. Okay, remember your O-level chemistry matters book, it had 1/1840 or 1/1836, one of these two values quoted over there as well, right? So but these are not the actual values of their masses, these are just comparative values. Okay, meaning electrons are way lighter than the neutrons and the protons. Okay, and protons and neutrons, they are equal in masses. So this is the complete table that many students find confusing, because they've learned about the actual charges and actual masses of protons and neutrons, and they think that these are the values of actual charges. But guys, these are not the actual charges nor the actual masses, these are the relative masses and the relative charges that are given over here. Clear? Then let's come to the structure of an atom. What does an atom look like? Okay, so an atom has a centrally located nucleus, you know this from your O levels, and it has electrons around the nucleus, right? Now in your O-level chemistry, you must have studied that the electrons are present in the shells around the nucleus, and within the nucleus you've got two of these subatomic particles. You've got the protons and the neutrons located inside the nucleus, and around the nucleus you've got the electrons located. And in your O-levels, remember you studied that electrons are present in in their orbits around the nucleus, in circular orbits, remember? But guys, now in your A-level chemistry, let me tell you that that was not the correct explanation, not the correct structure of an atom. Okay, this was the structure given by, or the atomic structure, or the representation given by Niels Bohr. Remember, there was a scientist called Bohr, B-O-H-R, Niels Bohr. He said that these shells are circular, but in reality they are no shells, they are not circular, they are elliptical, then someone said. But after some time we found out that no, they are not even complete shells, but rather there is just an electron density around the atom. But anyways, you don't need to go into that detail, of course it's not a part of our syllabus. But for now, you just remember that you've got a nucleus, centrally located nucleus, which contains the protons and the neutrons, and around the nucleus you've got the electrons in an electron density, in a spherical density. Okay, this is a spherical density of an electron. But this doesn't mean that this structure is wrong or nullified. We still use it. It's a conventional atomic structure, and we will be using it throughout our AS chemistry as well. So let's stick to the conventional structure. You guys know what conventional means, right? Conventional means something that has been followed since the beginning. Okay, so it's the conventional structure of an atom. Now let's move on to this atomic structure. So you guys know that around the nucleus you've got the electron shells. From your O-level chemistry, these shells have several names. The shells can also be called energy levels, or they can also be called orbits, or they can be called energy shells or energy levels, etc., etc. Now the shells closest to the nucleus have the least energy, the shells far away from the nucleus have greater energy. Okay, the first shell, as you guys know, okay, how to calculate the total number of electrons that can be accommodated in a particular shell. You guys know this from your, okay, some of you might know this from your O-level chemistry and some of you might not. I didn't know it in my O-level chemistry. What's the formula for calculating the maximum number of electrons which can be accommodated in a particular quantum shell? And by the way, this shell is also called a principal quantum shell. Okay, this is a complete name of a electron shell, principal quantum shell. It can also be called a quantum. okay, and each shell is given there a particular number. The first shell is given as the number 1, n is equals to 1. The second shell is given the number 2, the third shell is given the number 3, and so on. As you keep on increasing, the number increases. As the number increases, the number of electrons that each shell can accommodate also increases. Okay, for example, and how are you going to calculate the maximum number of electrons that can be accommodated in a particular shell? Well, for that you'll need to use this formula over here. The total number of electrons in a particular shell can be calculated using the formula 2n squared. 2n squared, where n represents the principal quantum number or the principal quantum shell of that particular shell. Okay, so if you want to find out the total or maximum number of electrons present in the first shell, what are you going to do? You're going to place the value of n as 1. So 2 times 1, and you are going to square it, and you'll get the maximum number of electrons in that particular shell. So 2 electrons can be accommodated in the first shell, and you know that from your O levels as well, that yeah, 2 electrons can be accommodated in the first shell, right? So this was actually the formula by which we calculated the number of electrons in that particular shell. Then after the first shell comes the second shell, in which the value of n is going to become 2. So 2 squared into 2 is going to be 8 electrons, and we know that in the second shell we have 8 electrons, and no more than 8 electrons can be accommodated. Then in the third shell we've got 18 electrons according to this formula, and so on. You keep on increasing the shell number, you keep on increasing the maximum number of electrons that can be accommodated in that particular shell. Now okay, before I go on to the lower formula, let's move on to the species which are found within the shells as well. And this is, of course, I'm assuming you guys know this already because this is a revision class, a crash course. Okay, now first of all you've got electron shells. Okay, this is a big electron shell in which, let's say, we've got 18 electrons, and of course we've got 18 electrons in the third shell. Now within the shell you've got smaller regions. You know that within the shells you've got smaller regions, and I'm assuming you guys are already have done most of your syllabus, so yeah, you might know this. Okay, so within the shells we've got subshells. Subshells meaning, sub means, what does sub mean? Sub means inside. Remember subatomic particles, subatomic particles. So subshells are basically present inside the shells. These are smaller regions, okay, present inside the shells. And then these subshells are of basically of 4 types, okay. And each type is given a particular name. There is an S subshell, there is a P subshell, there is a D subshell, and there is an F subshell. Okay, these are the 4 subshells that we have over here. And within the subshells we've got even smaller densities, smaller regions called the orbitals. These are not orbits, okay. Orbit is different and orbital is different. Orbit was the principal quantum shell. This entire one shell is called an electron orbit. Remember, I told you these are the different names given, but orbitals are found inside the subshells. And within the orbitals you don't have suborbitals, okay. You don't have suborbitals. Do not confuse this. You don't have suborbitals. Within the orbitals you've got the electrons, okay. Within the orbitals you've got electrons, okay. And if you guys are asked to define what an orbital is, so orbital by definition is basically that location of an atom where the probability, the chance of finding an electron is the greatest, is an orbital, okay. And by greatest I mean 95% chance. There is a 95% chance that an electron will be found inside that orbital, because you know that electron density keeps on revolving around the nucleus. Excuse me, it's not stationary, right? So since it's not stationary, therefore it keeps on revolving around the nucleus, and therefore there is the greatest chance is present over here inside the orbitals. You've got electrons. Okay, now in each of these subshells we've got different number of orbitals, okay. In the S subshell is the smallest subshell, and its S subshell contains only 1 orbital. Okay, and this is what I would want you guys to learn, and of course you need to learn this, because if you need to proceed on to this chapter, you will definitely need this for your electronic configuration of A levels. Okay, you've learned the conventional electronic configuration. Over here you're going to learn the advanced electronic configuration. Okay, now in the S subshell you've got only 1 orbital, okay, 1 orbital only, and that orbital is called the S orbital. Okay, its name is S orbital because it's found in the S subshell. Then comes the P subshell. Inside the P subshell you've got 3 orbitals, and they are called the 3p orbitals. The p orbitals found inside the P subshell, so therefore they are called p orbitals. There are 3 orbitals inside the P subshell. And Each of these orbitals have a particular name. The first one is called a px, the second one is called a py, and the third one is called a pz, okay, or a pz. Then comes the d orbital. The d orbital is larger than the p and the s. It has 5 orbitals. 5 orbitals. Okay, and it has 5 d orbitals. Basically, they are found in the d subshell. Therefore, they are called d orbitals. And they also have names dxy, dxz, dyz, dx squared minus y squared, and dz squared. Okay. And then comes the f subshell, and f subshell is the largest, containing 7 orbitals. Okay, it contains 7 orbitals, and 7 orbitals, 7 f orbitals, and you don't need to know the names of these. Okay, it's gonna be way too much for you guys, but still, and it's not a part of the syllabus as well. Okay, now these are the numbers that you are supposed to learn, that within the s orbital, s subshell, you've got 1 orbital, within the p subshell, you've got 3 orbitals, within the d subshell, you've got 5, and within the 7 subshell, you've got 7. Within the f subshell, you've got 7 orbitals. And guys, remember, inside the orbitals, you've got electrons, right? Within every orbital, within one single orbital, any one orbital, you can have a maximum of only 2 electrons. This is what you need to run. Within every, I think I wrote it somewhere down. Yeah, here. Each orbital can carry a maximum of only 2 electrons. Okay? What do I mean by this? Basically, if I have this 1s orbital, right? In this 1s orbital, I can only accommodate 2 electrons. I cannot accommodate more than 2. Okay? And the electrons are shown by the superscript, by the power of this s. This is how you show the electrons present in the 1s orbital. Okay? In the p orbitals, in the p subshell, I should rather say, how many electrons am I supposed to accommodate? I've got 3 orbitals, right? 3 orbitals. 3 orbitals are found. 3 orbitals are found in the p subshell. And each orbital can carry a maximum of 2 electrons. So what's the total number of electrons present in the p subshell? 6 electrons, right? Because we've got 3 orbitals and each orbital has 2 electrons. So 2 plus 2 plus 2 is 6. Similarly, a d subshell. A d subshell has 5 orbitals and each orbital has 2 electrons. So the total number of electrons present in this d subshell are gonna be 10 electrons. Similarly, the f subshell has 7 orbitals and each orbital has 2 electrons. So the total number of electrons found in the f subshell are going to be 14 electrons. Okay, 14 electrons are found in the f subshell. 10 electrons can be found in the d subshell. Then in the p subshell, you've got the 6 electrons, and in the s subshell, you can only have a maximum of how many electrons? 2 electrons. And this is the maximum value. Okay, you can have less than these electrons in these orbitals, but you cannot have more than these number of electrons. Okay. And this, so now, excuse me, how are you gonna calculate which shell has how many orbitals? So this is the formula for calculating the number of orbitals found in particular shell. Now let's look at the first shell. The first shell has 2 electrons. The value of n is 1, right? 1 squared means only 1. 1 means you've got only 1 orbital in the first subshell. And that's true. We only have 1 orbital. That's the reason why we can only accommodate 2 electrons in the first subshell. If we had more than 1 orbitals, then we would have accommodated more electrons. But since we only have 1 orbital in the first subshell, sorry, in the first shell, therefore we can only have a maximum of 2 electrons in here. And the very first orbital that can be accommodated, or the first orbital that we have to consider by convention, is the s orbital, because s orbital is an orbital at the lowest energy. Okay, it has the least energy. Then comes the p orbital. The p orbital contains, since the value of n is 2, it's gonna be, sorry, not the p, it's the second shell I'm talking about. 2 squared means 4 orbitals. Okay, the 4 orbitals that it will contain would include 1 s orbital and 2 p orbitals, sorry, 3 p orbitals. Okay, so basically in the second subshell we can have 4 orbitals. 4 orbitals means 8 electrons, right? They mean 8 electrons because 4 times 2 is excuse me, 4 times 2 is 8. So therefore they contain 8 electrons. Similarly, if we go on to the third shell, in the third shell, the number of orbitals that we would have are going to be 3 squared. And 3 squared means 9 orbitals. 9 orbitals. The 9 orbitals that we have in here. So 9 orbitals mean how many electrons? We've got 18 electrons in there. The 9 orbitals that we would have would include the s orbital, the p orbital and the d orbital. Okay, 1 orbital from the s subshell, 3 orbitals from the p subshell and 5 orbitals from the d subshell. When you add them, you'll get a total of 9. Right? And in the next lecture, we are going to talk about the electronic configuration of 1s, 2s, that including the Aufbau's principle and the Hund's rule and electronic configuration after this lecture. Okay, so thank you.